Chapter 1, Introduction to Cloud Native. This chapter covers what the cloud and cloud computing model are, the definition of cloud native, characteristics of cloud native applications, culture and practices supporting cloud native, when and why you might consider the cloud native approach, topologies and architectures for cloud native applications. Cloud-native applications are highly distributed systems that live in the cloud and are resilient to change. Systems are made up of several services that communicate through a network and are deployed in a dynamic environment where everything keeps changing. Before diving into the technologies, it's fundamental to define what cloud-native is. Like other buzzwords in our field, such as Agile, DevOps, or microservices, cloud-native is sometimes misunderstood and can be a source of confusion because it means different things to different people. In this chapter, I'll provide you with the conceptual tools you'll need for the rest of the book. I'll start by defining what cloud native means and what it takes for an application to be identified as such. I'll explain the properties of cloud native applications, examine the characteristics of the cloud computing model, and discuss when and why you might want to move to the cloud. I'll also present some fundamental concepts of cloud-native topologies and architectures. Figure 1.1 shows an overview of the different elements I'll cover in this chapter as I define and qualify cloud-native systems. At the end of this chapter, you'll be ready to start your journey building cloud-native applications with Spring and deploying them to Kubernetes.
Figure 1.1. Cloud-native is an approach to application development aiming at leveraging cloud technologies.
Section 1.1. What is cloud native? On May 25, 2010, Paul Fremantle, a veteran of the cloud industry, wrote a post on his blog titled Cloud Native. He was among the first to use the term cloud native. At a time when concepts and technologies like microservices, Docker, DevOps, Kubernetes, and Spring Boot didn't yet exist, Fremantle discussed what it takes for applications and middleware to work well in a cloud environment, to be cloud native with his team at WSO2. The key concept explained by Fremantle is that cloud-native applications should be specifically designed for the cloud and have properties that take advantage of the cloud environment and the cloud computing model. You can move a traditional application, designed to run on the ground, to the cloud, an approach commonly referred to as lift and shift, but that doesn't make the application native to the cloud. Let's see what does. Section 1.1.1, the 3 Ps of cloud native. What does it mean for applications to be designed specifically for the cloud? The Cloud Native Computing Foundation, CNCF, answers that question in its cloud native definition. Cloud native technologies empower organizations to build and run scalable applications in modern, dynamic environments such as public, private, and hybrid clouds. Containers, service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. These techniques enable loosely coupled systems that are resilient, manageable, and observable. Combined with robust automation, they allow engineers to make high-impact changes frequently and predictably with minimal toil. From this definition, I identify 3 points that I like to call the 3 Ps of cloud native. Platforms. Cloud-native applications run on platforms based on dynamic, distributed environments. The clouds, public, private, or hybrid. Properties. Cloud-native applications are designed to be scalable, loosely coupled, resilient, manageable, and observable. Practices. Practices around cloud-native applications, automation, continuous delivery, and DevOps include robust automation combined with frequent and predictable changes. What is the Cloud Native Computing Foundation? The Cloud Native Computing Foundation, CNCF, is part of the Linux Foundation, and it builds sustainable ecosystems and fosters communities to support the growth and health of cloud-native open-source software. The CNCF hosts many cloud-native technologies and projects to enable cloud portability without vendor lock-in. If you want to discover the many projects addressing any cloud-native aspect, I recommend checking out the CNCF Cloud Native Interactive Landscape. Footnote A, Cloud Native Computing Foundation, CNCF Cloud Native Interactive Landscape, landscape.cncf.io. In the following sections, I'll examine those concepts further. However, I'd first like you to notice how the definition of cloud native is not tied to any specific implementation detail or technology. The CNCF mentions some in its definition, like containers and microservices, but they are just examples. One of the common misconceptions when starting a migration to the cloud is that you have to adopt a microservices architecture, build containers, and deploy them to Kubernetes. That is not true. Fremantle's post in 2010 is proof of that. He didn't mention any of those because they didn't exist. Yet, the applications he described not only are still considered cloud native, but they also comply with the definition given by the CNCF 8 years later.